Question 1. A ball is dropped from an initial height of d feet above the floor and repeatedly bounces off the floor. Each time the ball hits the floor, it rebounds to a maximum height that is 3/4 of the height from which it previously fell. The function h models the maximum height in feet to which the ball rebounds on the nth bounce. Which of the following is an expression for hn? So I have a ball that I have thrown, right? And then it rebounds. And every time it rebounds, it reaches 3/4 of the height that it reached in the previous bounce, right? So this is an exponential function. So I should use A is equal to P times growth factor to the power T, right? Where growth factor is 3/4 because every time it bounces 3/4 of the previous bounce. The initial height is D because we start with D. And the bounce T itself is N, right? For example, when N is 0, it is A is D times 3/4 to the power N. So when N is 0, that is when there is no bounce, then the initial height from which it is thrown is D. After the first bounce, it would be 3/4 of D, and then so on, right? So it would be 3/4 to the power N times D, option A. Question 2, the figure above shows the graph of a polynomial function G. Which of the following could define G? So here I see that there are 3 x-intercepts, right? So I'm looking at a polynomial with degree 3, right? So the first thing I can do is I can eliminate option D. How would the graph of option D look? So if I take x squared common, I get x squared minus 4. So this is a graph with roots at 0, 0, 2, and minus 2. So this would look like this, minus 2, 2. This would come like this and go like this. Because there is a repeated root at 0, the graph would turn from the axis at 0, right? And so this is how the graph of option D would look. Now, the first thing you should remember is that when I have a graph with an odd degree, which is what I have in this case, if the graph starts from the left bottom and finishes at the right top, the leading coefficient, which is denoted by A, is positive. And if the graph starts from the left top and finishes at the right bottom, the leading coefficient is negative. So we have this second case here, right? The graph is starting from here and finishing here. So the leading coefficient in this case would have to be negative. And the only one with the leading coefficient negative is option C. So this should be my answer. Now, why does this happen? You can verify it. So for example, let me first show you why this would look like this. So if I take minus x common, I would get x squared minus 4, which is minus x times x plus 2 times x minus 2. So my roots are at 0, negative 2, and plus 2. And since the leading coefficient is negative, the graph will start from the left top and finish at the right bottom. And you can verify this by taking any value between minus 2 and 0, let's say minus 1. So when I put minus 1 in this equation, let me write here. So I'll get minus of minus 1 times 1 times minus 3. So that becomes negative 3. So I get a negative value, right? And so this is how the graph will look. If I had drawn the graph like this, then at minus 1, I would have gotten a positive value, which is not correct. So you need to remember this rule about how the leading coefficient decides the graph for an odd degree function. Okay, how would this option B look? Option B would look like this, what I have drawn here. because it has the same roots, x times x square minus 4. So x times x minus 2 times x plus 2. So this has -2, 0, and plus 2. But because the leading coefficient is positive, it would start from the bottom left and finish at the top right. And what about this one? This is simply the graph of y is equal to x cube, which looks something like this. Shifted 4 units down. So let me change the color. So that would look like this, right? Where this point would be 0, -4. So this is simply the graph of x cube shifted 4 units down. So this is not what we are looking for. So the right answer is option C. Question 3, the table above shows some values for the function f. If f is a linear function, what is the value of a plus b? Okay, so since it's a linear function, I can write the function fx as y is equal to mx plus c, right? Where m is the slope of the line and c is the y-intercept. And I have a point which is given to me, so I can say 32 is 10m plus c, right? By substituting these values. Now, let me also write equations for a and b. So a will be 5m plus c, and b would be 15m plus c. And since I need to find a plus b, I'm going to add these two equations. So I'll get 20m plus 2c. Now, I notice that this is 2 times the right-hand side of this equation, right? So if I multiply this equation by 2, I would get 20m plus 2c is 64. And so a plus b is also 64. Question 4, in the xy plane, the graph of y is equal to x squared plus bx plus c is symmetric about the line x is equal to 3 and passes through the point 5, 2. What is the value of c? So this is a parabola, and we are told that it is symmetrical about the line x equal to 3. So let's say this is the line x equal to 3. So my parabola will look something like this, right? Now you need to understand that because it is symmetrical about this line, if the graph passes through the point 5, 2, so let's say this point is 5, 2. So this is 2 units to the right of the line x equal to 3. So if I go 2 units to the left of the line, then I'll get the same y coordinate, right? So which means that 3 minus 2, 1. So 1, 2 will also lie on this parabola because the graph is symmetrical about x equal to 3. So now I have 2 points on the parabola and I have 2 unknowns. So I can substitute these values to find b and c. So let me first put 1, 2. So I get 2 is 1 plus b plus c. So that gives me b plus c is 1. And the other equation I can get by substituting 5, 2 in the equation. So that would be 2 is 25 plus 5b plus c. So that would give me 5b plus c is minus 23. So that's my second equation. Now, since I need c, I should multiply this equation by 5. So my equation becomes 5b plus 5c is 5. And the other equation is 5b plus c is minus 23. And now if I subtract these two equations, I would get 4c is 28. And therefore, c is going to be 7. So the value of c is 7. Question 5, what is the x-intercept of the graph of y is equal to 1/8 of x to the power 3 by 2 minus 8? So at the x-intercept, the value of y is 0. So I can say 1/8 of x to the power 3 by 2 minus 8 is 0. So 1/8 of x to the power 3 by 2 is 8. So x to the power 3 by 2 is 64. So x is 64 to the power 2 by 3. And 64 is the cube of 4. So 4 to the power 3 to the power 2 by 3. The 3's cancel. So 4 square is 16. So the x-intercept would be 16, 0, which is option C.